Okay, so we are going to start a new topic today, that is our work, energy, and power. Okay, that topic is work, energy, and power. Actually, this topic is related with your idea of force when it is converting that into energy. Uh, okay, so when we are talking about that force is making energy, or force is being utilized for energy, that is called your work done. Okay,
Yes.
so I just say that the product of force, when we apply a force on a body, what happens? That force displaces that body from point A to point B. Let's say this is your point A, this is your point B. So when that body has been displaced through this position, or from this position A to position B, then the product of that force, how much force we are applying and how much distance we are going to travel, or going how much displacement we are going to uh, provide to that body, when we are going to multiply both of them, we get work. So work is basically defined as the product of force and distance moved in the direction of force. Okay, in its direction or in the direction of force. So you have to remember this definition. It is asked for 1 mark. And then its formula for the burden, that W is equals to F into T, where W is work, F is the force, constant force, and that is made into Newton, and D is the distance moved in the direction of the force in meters. So when I say what will be its unit, so its unit will be joule. Is it? Do you agree with that?
Yeah.
Its unit is
Yes.
joule. So when we say, or when we say that how much work is 1 joule, so it is defined as work is 1 joule if we are applying 1 Newton force and that body is moved through a distance of 1 meter. Then this is, the work is called 1 joule. Is it clear to you? Right, when the work is equals to 1 joule, when you are applying, actually here by equation it is very clear to you that work done is equals to force into distance or displacement. So this would be 1 joule if this is 1 Newton and this is 1 meter. So 1 Newton into 1 meter is equals to 1 joule. So it's very simple to understand. Now I would have some other considerations. Other unit of the work is Newton meter, which is obtained from this equation, but that is not SI unit. Remember this thing, right? Now, here there are some important things to be understood. One of them is that this person is applying a force without any motion. There is no motion at all. So, do you think that it is doing some work?
Uh,
This
no.
one, diagram A, in which that boy is applying some force on this mm, card, and is there any work? No,
Mm.
because because it is not displaced, because displacement is equals to 0. This is one situation. But when work is, our body is not displaced in the direction of force, I mean it is, when it is displaced perpendicular to the direction of force, at that time work is also 0. So if you are applying force in any direction, let's say in the upward direction, this is your force, and displacement is over there in this direction, then they are, both of these are perpendicular to each other. Is it? They are making 90-degree angle. So here work is equals to 0. So remember this thing. This is also a condition that when force and displacement are perpendicular to each other, then work will be equal to 0. Okay. Okay.
Yes.
So when we say that no work is done when the object does not move, here I have shown that. Secondly, the direction of force and direction in which the body moves, they are perpendicular to each other. This is the second condition when work will be zero, and third when there is no force. Definitely, if you are going to apply no force, then there will be no work. So here I have some diagrams for you, some examples in front of you, and in these examples, in this diagram number one, there is a girl and she is having a box in front of her, and she's applying some force in the direction of I mean, this is the direction of force, and then the direction of motion is the same. So if we say that force and displacement, they are in the same direction, so she is doing some work. Yes, she's doing. But here, if she's lifting a bag, check this one out. She is basically applying the force in the upward direction and she is traveling in this way, right? This is your displacement and this is your force you have applied. So both are at 90-degree to each other, so she is doing no work. Are you getting it? Similarly, when she is going to lift a load, there is a load and she is applying a force in the upward direction, right? She is applying a force in upward direction. Similarly, the displacement is also same because that box was over here and it has been displaced over there. So displacement is in the upward direction, displacement, and then force is in the upward direction. So both are in the upward direction. So yes, work is done. So here she is going to move it. She is holding it up with a force in the upward direction, but she is moving it towards here. This is your displacement. So when she is moving it towards right and applying the force in the upward direction, there is no work. So if I summarize this all diagram, work is done when force and displacement are in the same direction. Force and displacement are in the same direction. When they are perpendicular to each other, when they are at 90-degree to each other, no work is done. Check this one out. No work is done. No work is done. Okay? Is it clear to you?
Yes.
Okay. Now let's have uh, another concept, that when we do some work, that work is actually stored in different uh, objects or in different bodies in the form of energies, right? So here I'm talking about work is converted into kinetic energy. So when work is converted into kinetic energy, then that body moves. Definitely it has mass. So when a body moves, when it accelerates, actually it does work. When we do a work on an object, it gains kinetic energy. I mean, gain kinetic energy mean we are going to speed it up. So it is your speeding up. What is that? It is speeding up, right? So when we are going to speed up the body, we are providing it energy. If there is no dissipative forces, I mean friction or air on an object. So for example, I was discussing about an example, that box which was over there. 5 joule of work is done on pushing a box, will transfer to gain in 5 joule of its kinetic energy. I mean to say that if she is pushing the box over here in the first diagram and she is doing 5 joule of work on it, then definitely this block will have some kinetic energy, and that kinetic energy will be stored in it, 5 joules. But 5 joules are to somehow the kinetic energy in the way. I will discuss the equation and all that stuff again. Let's go through this with another way. Then when we lift a body up, our body moves down. It has the change in kinetic energy. Then work is being done by gravity. When work is done by gravity, here this is actually work done by gravity, or you can say work done against gravity. In this one, when an object is moved upward, this is work done against gravity. Work done against gravity. So here, when you are going to do some work against the gravity, or work is done by the gravity, in both of these cases, gravitational potential is energy is possessed by the body. So gravitational potential energy is the energy of the body due to its position above a reference level or a point. In order to find the gravitational potential energy of an object near the surface of the earth, we need to consider the work done to lift the object of mass m through a height h above the reference level. So actually, I'm going to move towards uh, energy. I will move to, or I will talk about kinetic energy. Then I will talk about potential energy with details. So here, what is energy actually? Generally, an energy is, what is an energy? Energy is how much work is done by an object. I mean, here in the above two examples, or in above two discussions, I just told you that when the work is done to move an object, it is considered as its kinetic energy, and when the work is done to lift an object, it is considered to be its gravitational potential energy. So remember one important thing, that energy is the ability or capacity to do some work. So its unit is again and joule. So it is a scalar quantity. What an energy is, it is a scalar quantity. So it has only magnitude, no unit, no direction at all, right? Magnitude and unit. Okay, so remember these two things. uh, I will talk about, yes, this concept. But before that, when I was talking about energy, there is a principle of conservation of energy which is just considered over here. Later on, we will apply this. The principle of conservation of energy tells us that energy can be converted from one form to another form, but Shukrullah, total energy remains unchanged. Okay, remember this. Energy can be converted from one form to another form, but total energy remains unchanged. Yeah, yeah.
Same.
Do you agree?
Yes.
Same. It remains same. So when that energy remains same, so I have several definitions for that. The total amount of energy remains unchanged. The total amount of energy of a closed system remains constant, or energy can neither be created nor be not be destroyed, but it can be converted from one form to another form. So there are so many ways to define it. So energy can be converted from one form to another, that's it, without any loss.
Okay.
Without any loss, you can say
Okay.
in this, without any loss. So this means that when, for example, when we are going to burn a wood or fuel, we convert the stored chemical energy into heat and light and different forms. So is it clear? Now it can also be transferred from one body to another through work done. For example, when we rub the hands, you know what happens?
Yeah, kinetic energy is transferred.
Yes. And when you are sitting in front of heater, what happens?
Heat energy is transferred. You heat up.
Yes. So here there are several forms of energy. Actually, there is a chapter ahead which is called as energy resources. Right? The name of the chapter is energy resources. So we will talk about all these energies and their resources and their nature, whether they are renewable or non-renewable or whatever they are. We will discuss in that topic. Okay. Here
Yes.
I'm talking about That's these forms of energies are the potential energy. Potential energy is basically hidden energy. What do we call about potential? Potential is a hidden energy. I will explain all of them one by one. It can be elastic, it can be gravitational, it can be chemical. Okay. Kinetic energy is the energy due to motion of a body. It is that's why it is called your mechanical energy. Then electrical energy, due to flow of charge or due to current. Then thermal energy due to heat. Then light, nuclear, geothermal. There are so many, but mainly the calculations are in kinetic energy and gravitational potential energy. And from your electrical current, electrical quantities, there is electrical quantity or electrical energy. When I will reach to that point, I will explain it to you. Here there is simple concept of kinetic energy. Is it clear to you? So when I say
Yes, okay.
that what is kinetic energy, so I told you that the energy possessed by a body due to its motion. Moving bodies, moving objects have kinetic energy. So if I say that moving bodies have kinetic energy, so definitely they must have they must have some motion or impact of motion. So if I consider that m is mass of the body, v is speed of the body or velocity of the body, it does not matter because it is squared. So kinetic energy formula is half mv square. So you have to recall it. Is it easy or not?
Yeah, it's easy.
It's very easy. I mean, it's not a big deal. Where m is the mass, v is the speed or velocity, and then SI unit of the energy is joule. So whatever the form of energy do you select, its unit is joule. Now let's talk about the kinetic energy. Here, the mass of the car is m, its speed is v, so its kinetic energy is 1 by 2 m v square. Okay, let's talk about the potential energy. So when I talk about potential energy is the stored energy. What is the potential energy? That is the stored energy. For example, the chemical energy is stored in terms of chemicals in our body or in the food what we take. When we burn the wood, chemical potential energy is converted into thermal energy and so on. I told you about that. But here, what we are talking about, that is gravitational potential energy. What is that energy? It is your gravitational potential energy. Okay, gravitational
Yes, correct. Okay.
potential energy. Yes. So gravitational potential energy is basically that energy which is due to mass value of g. I mean, this is actually the weight of that body, which is due to weight and height. Actually, this is this scene, weight and height from the reference of the ground. So if this guy is lifting a mass m at a height h above the surface, so what amount of gravitational potential energy does it hold? That is that is m is its mass, g is its gravity, so mg n times h. So it is very simple that its gravitational potential energy at this position is mgh. Okay, so what is the equation for gravitational potential energy? mg
MGH.
mgh, right? So here I have mentioned it and again that its equation is mgh, that is due to height. Now when the height is increased, gravitational potential energy increases. When height decreases, gravitational potential energy decreases. So I have simply explained in this paragraph that when an object is moving downwards, its gravitational decreases and its kinetic energy increases, right? For example, when we are going to uh, drive a car down the hill, what happens? All of the gravitational potential energy is gradually converted into kinetic energy just before if it hits the ground. Mean Yes, when that mass would be released, this mass, what will happen? When it would be released, it would hit the ground over here, but when it will when it will hit the ground, all of its kinetic potential energy is converted into kinetic energy. That's why it will damage the floor, because it has all of kinetic energy stored in it, and that comes from its potential energy. And potential energy is coming due to its height. So I'm saying that, for example, here is a person who is going to lift a load, lift a stone. At this position, that is at rest. This stone is at rest. So
Rest.
all of its energy is actually potential energy. Here it is potential energy. Kinetic energy is equals to zero. So no red line. But here at this position, it has some height. This stone has some height halfway, as well as it is moving down. So it means that potential energy which is being lost, this blue line is decreasing and red line is increasing. So they are going to be equal. But remember this thing, blue is decreasing and red is increasing. So I can say that blue will decrease, 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 and finally it will reach to zero. But this red one was zero over here. Now it is increasing, increasing, and increased a lot. It means all of its kinetic energy is converted into potential energy. So here, if I say that the total energy, this equation is for total energy, is equals to kinetic energy of the system plus gravitational potential energy of that body. So if I say what is kinetic energy, it is your 1 upon 2 mv square, and that is equal to mgh. So is this clear to you? So total energy, when
Yes.
kinetic would be zero, total energy will be equals to mgh. But when this would be zero, total energy will be equals to kinetic energy 1 by 2 half mv square. Is this clear to you?
Yes.
Got it? So this was
Got it.
basically the actual concept of gravitational potential energy and kinetic energy. Let's have an example of simple pendulum. In this simple pendulum, if I tell you that at position A, um, this pendulum is in equilibrium position, right? Equilibrium position means it does not have any height at this point, so it does not have potential energy, right? But at point B, this point, it has some height, the maximum height rather, not some height, the maximum height during its journey. So it has the maximum potential energy over there. But as it is at rest, it stops, then it moves back. That's why its kinetic energy is equals to zero. Are you getting it? So
Yes.
when it is moving down at this point, its speed is maximum. Its speed is maximum. So when it has maximum speed, that's why kinetic energy is maximum. Again, when it is moving up, its speed decreases and height increases. It means from A to C, gravitational potential energy increases and kinetic decreases. So all of these situations, either one energy is decreased and other increases, are first it decrease and second increase. So this, gain and loss is continuous until unless friction appears in between. So when there will be friction, this loss and gain would be ultimately finished up, and all of the energy would be lost, and this pendulum will be stopped. Are you getting it?
Yes.
Okay.
Yes, I
So this all is I have explained it to you. Now here is the new topic, that is the energy loss due to resistive forces. What is energy loss? Energy loss due to resistive forces. Okay. So let me explain you one of the example before going through this topic are okay. Just wind up this and then we will talk about some examples, about examples from past papers. Okay, so when there will be actually in our daily life there is no ideal situation. So what happens, there is a huge friction. So when there is a friction, so some of the total energy is lost in terms of thermal energy. So that thermal energy dissipated in the surrounding, right? And we cannot convert it into kinetic energy or gravitational potential energy. That's why, what do we say, that uh, when the energy is lost by the pendulum, because I was talking about that example, that's mean then it reaches to the lower heights and successive swings. And please note down that total energy is still conserved. This is very important. I'm not talking about total energy. Total energy is still conserved because heat is also a form of energy. Got it? The total energy refers that the statement of total energy in the universe, right? The difference between loss and gain will never be equal. This is very important strategy. That what I'm talking about, that when there will be friction, then gain and loss would never be equal. The difference between loss of energy and gain of energy is equal to the work done against friction. Before that, there was no work done. That's why loss minus gain was equals to zero. But here it is not. Remember this thing. This is very important equation, that if E loss minus E gain is equals to zero, so no work done against friction. No work against friction. Are you getting it clearly?
Yes, sir.
Okay. So the friction force is work done against friction divided by distance traveled through the body. So as you know that when we are having some sort of uh, work done, then it is very easy to understand that work done is equals to F into D. And when we are talking about friction force, that is equals to work done against friction divided by D. So it means, let's say, I have a question, or I have some equation, that if I have a body and that body is moving down the hill by mean of any source, or we can say that is due to some reason. Okay, let me open up your section and then we will talk about that energy loss. Okay, I can have a new document. No, let me open some pages. Yes, I have added a blank page behind it. Now, in this one, I'm going to explain you actually what does it mean by law of conservation of energy. For example, you have a roller coaster, okay, and here a ball is there, and its mass is 2 kg. How much mass does it have? Its mass is 2 kg at rest. At rest. And that is at a distance h above the surface. Okay, this is a ball of 2 kg, and the height above this is actually this one. Let's say that height is 10 meter. Or do you have calculator?
Yes.
Okay, then I can place any other value. So here is, tell me one thing. Let's say this is your position A, here will be its position B, and I can mark any other position. I will mark it later on. What will be the potential energy at point A? Can you say that it can be mgh? Okay, so mass is 2 kg, G is 9.8, and H is 12. So what will be your answer?
So just a second.
Yes.
Yes, sir. I couldn't hear you.
Sorry.
I couldn't hear you. You just say something. Next. Answer is 235.2.
Wait. I will open up my calculator and then I will calculate that. It is how much? Uh, 2 times 9.8 times 12.
Yes. 235.2.
Yeah, 275.2. Is it?
Yeah, 235.
235. Oh, sorry. 235. So almost this body is having 235 joule of energy in the form of gravitation potential at this position. Now, if I say that the ball is reaching at this point, okay, the ball reached at this point. During this or in between, there is no friction at all, no energy loss in the form of heat. So at point B, what do you say? At point B, what about its kinetic energy? It will be equal to 1 by 2 m v square,
Mm,
is it?
yes,
But
MV.
because we do not have speed, so I can say that according to law of conservation of energy, according to law of conservation of energy, loss in energy, loss in gravitational potential energy is equals to gain in kinetic energy. So I can simply apply that the kinetic energy at point B will be how much? 235 joules. Do you agree?
Yes.
Okay. So if you are agreed, then let me know what will be speed at that point.
So we have the mass, we have the
Yes.
energy.
Yeah.
So we have the mass and energy, right?
Yes. It will be equal
So
to 1 by 2 mv square. So the speed will be equals to 2 times kinetic energy divided by mass. And then finally we have to take square root of that. Don't worry about that. If you think that this equation is,
no, it's not. No,
horrible,
no, it's
it's very simple. 2 times 235 divided by 2 square root, because 2 kg was the mass, so this would be gone. So what will be your speed? What is square root of 235?
square of 235
Square root
of 235.
15.3
Yes, approximately.
meters per second. It means this ball has to reach at this point with this much speed. Are you agreed?
Yes.
But if I say that if the ball reaches the point B with 14 meter per second, 14 meter per second, then calculate what? Calculate the work done against friction, right? Work done against friction, or you can simply say energy dissipated as heat, or energy dissipated as heat. Okay.
Yes.
Okay. Now I will say that in this case, loss in GP, because gravitational potential energy is lost. Do you agree?
Yeah.
Minus gain in kinetic energy is equals to work done against friction. Work done against friction. Okay.
Yes.
Okay. So just put the values. What is the loss in GP? It is 235. But now gain in kinetic energy is to be calculated 1 by 2 mv square. So you will put the values back. 235 minus 0.5. 1 by 2 is 0.5 into 2 into 14 square. So you can say it is 235 minus 14 square is 2, sorry, 196.
Yeah.
Is it? Yeah, 196. So it means I got 39 joules of energy loss. Is it? As heat.
Yeah.
So here are here do we calculate this energy. Now, if I say that length of the track is, if length of track at which this ball is moved is 12 meters or 13 meter or suppose 3 meters. How much? 3
Three.
meters. Then calculate friction force. So how to calculate friction force? You know, W is equals to F into D. Is it? This shows that F is equals to W divided by D. So W is 39 and D is 3. So you will get 13 joule. Are you getting it?
Yes.
Sorry, 13 Newton, not joule. So this is what, how to calculate the energy loss and energy gain and all that stuff. So I hope that it would be clear to you.
Yeah, it is clear. No problem.
Is it clear now? So is it fine for today's lesson?
Yeah, it is. No.
Yeah. So
Yeah.
in next lesson, inshallah, we will discuss about power, efficiency, and all that stuff, and then we will do some past paper questions. Okay.
Yeah.